In this lesson we're going to look at how to calculate area between two graphs when we don't actually have a diagram. So the example says calculate area enclosed by the graphs of the functions g of x equals x plus 3 and f of x equals 6 minus x squared. So the first task here is to work out where the graphs intersect, and then we can get our limits of integration, our upper and our lower limits. And also do a wee quick sketch to find out what's the upper function and then the lower function so that we can subtract them in the right order. So, finding out where the graphs intersect. Well, they intersect when y equals y, if you like, so x plus 3 is equal to 6 minus x squared. So we'll set that out here. In order to solve this type of equation, which is a quadratic, you take everything over one side, set it equal to 0 and then factorise. So I'm going to add the x squared over, I'm going to add the x to get 2 x's, and I'm going to take away the 6 to get minus 3 equals 0. At that point I should be able to factorise this into double brackets, x's at the start, and then 3 and a 1, it's going to be a plus 3 and a minus 1 to make there 2 here. Then I can see that x is either negative 3 or 1. That bracket needs to equal 0 or this bracket needs to equal 0. So minus 3 or 1. Sub these back into any of these two to get your y coordinates for where the graphs intersect. I think this is obviously easier to work with here, the x plus 3. So we'll sub it into that one. They'll both give the same result, but pick the one that's easiest to you. Negative 3 plus 3 is 0. And sub 1 in, 1 plus 3 is 4. So there's your coordinates, negative 3, 0 and 1, 4, where they intersect. The next thing to have a wee look at is what the graph's going to look like. So x plus 3 is a straight line, gradient 1, intercept 3. This is a parabola with roots, and it's also a negative x squared, so that means it's a maximum turning point. So it's going to look something like this. Put your points of intersection in, draw in your maximum turning point, and then draw your straight line gradient 1 and roughly 3 here. So we can see what the upper function is. Again, if you look, just take this part here, and then we're looking between the two limits. And if I pick this point here, for example, that red line is lower than the blue line. Again, over here, this red line here is lower than the blue line. So the blue line is your upper limit, or your upper function, sorry, and your red line is your lower function. So the straight line is the lower one, the quadratic's the upper function. So we want to do this function subtract this function. And just a wee note to say that that's how we got these y coordinates using that there. So find the area between the graphs. Well, limits are negative 3 and 1 from the coordinates, negative 3 here and 1 there. And do your upper function minus your lower function. So that's this quadratic, subtract the straight line. Remember to put the straight line in brackets. It's really important that you do this bit here in brackets, because with the negative multiplier that will go to negative x and that will go to negative 3. It's a common mistake that people forget to make. When you're subtracting more than one term at once from something else, you need to put it in brackets. So that's going to simplify down to this. You're going to get a 6, take away 3 to give you your 3 here. That's going to be negative x, take away x, minus 2x, and then your negative x squared. So if we can integrate this properly, substitute in the 1 and the negative 3, we're there. We're going to get the right answer. So integrate the 3 to get 3x. This is really x to the power 1. So add 1 to the power, which is 2, divide, and you're going to get an x squared. Add 1 to the power to make it 3, divide to a third x cubed. Sub in your upper limit first, so put your 1 here, here, and here. Do a takeaway, and then do your negative 3 here, here, and here. It's just going to look like this. So that's just putting the 1 in the 3 places, take away and putting the negative 3 in the 3 places. So 3 times 1 is 3, 1 squared is 1, so it's going to take away 1, 1 cubed is 1, so it's going to take away a third. Then take away 3 times negative 3, which is negative 9, negative 3 squared is 9, so it's going to be a take away positive 9, and then negative 3 cubed is negative 27. If you want to third that, I've got negative 9, but you're taking away negative 9, so that's going to be a plus 9. Just be careful with your negative numbers. So these two cancel each other out if you like. So we've really just got to take away negative 9 there. 3 take away 1, that's 2. And 2 take away a third is 1 and 2/3. So this bit comes to 1 and 2/3 here, and you're going to have a plus 9. So 1 and 2/3 plus 9 is equal to 10 and 2/3, and that's your area between the graphs, 10 and 2/3 units squared.